Hello again, everybody. This is Joseph with a tutorial. Now, we're dealing with the wiper motor, and we're dealing with a washer motor. Two motors involved when it comes to wiping the windshield. Now, how to start the diagram, how to interpret it, where to start. Like I previously stressed, you always go for key components and something that catches your attention. In this diagram, something that catches my attention are the motors. It's something different that I haven't seen in the other schematics. The switches over here catch my attention. This fuse doesn't catch my attention because there's many fuses. This catches my attention, the control module over here for the wiper. Now, as I said, I'm focusing on key components, major components in a diagram. Where do I start? It depends if I'm trying to analyze and interpret the schematic or if I'm troubleshooting. And I'll explain what I mean. If I'm analyzing it, I'm saying, okay, how does the wiper motor work? How does the washer motor work? Well, if I'm interested in how the washer motor is working, I will find the washer motor over here. Then I'll say, okay, every motor needs 12 volts to be activated. So therefore, I'll say, okay, here's the symbol for it. Here's the washer motor. This goes to ground, fine. What about the other side? I know I need 12 volts for a motor. So I'll backtrack and I'll say, okay, what are these? These are switches. Okay, it's possible for current to flow through a switch to the motor. That makes sense. I'll go back up here and I'll say, okay, where does this go to? This goes to a switch. This goes to another switch. And this goes to a fuse. Now I'll say, okay, this makes sense. Which is the proper path for current to flow to activate this? I'll say it could go through the switches. It wouldn't go through this. It wouldn't go through this. It would go back to this, to the fuse, to get the B+. So in other words, B+ is feeding this line, this washer motor. That makes sense. Now, when is this being activated? You know, when you spray it, you wanna spray the washer fluid on the windshield. It's a mist. Therefore, when I'm spraying this, I'm spraying the fluid, but at the same time, there's a wiper that's wiping it. So two motors are being activated at the same time for that purpose. Sometimes I don't want a mist. Let's say it's raining. I'm not going to spray a mist from the washer. I just want the wipers to react. So this motor would be involved, not this. It depends what purpose you're doing, correct? So therefore, if I want to activate the washer motor, we just said we have current flowing through this from here. These are ganged together, like we said. Dotted lines means if I move this one, simultaneously, these move. Therefore, if 12 volts comes in here, 12 volts, the current also has another path for this to flow through this to give it 12 volts. So this has 12 volts. How do I know? And this has 12 volts. How do I know it's 12 volts? I don't lose anything. I don't lose any voltage through a switch. I lose voltage through a resistor, which we'll see in a couple of minutes. Therefore, I want to create a mist. I want to spray. Let's say the windows are dirty in the morning, and I want to clean it. You have to clean it with washer fluid, with a mist. Therefore, I'm going to put this switch. I'm activating the motor to wash it, to give a mist, and I'm activating this one, these switches. So therefore, now current can flow through this resistor. You see a resistor in series? Through this resistor. Now, through this path, there's 12 volts. Through this path, that's 12 volts minus a drop of R1. Okay? So therefore, in this path, You see, this is all gang together, dotted lines. That means whatever I move this position, this switch, I move this at the same time, I move this at the same time. So if this is in missed position, this is in missed position, this is in missed position. However, there's a difference. In missed position, I have a connection. In missed position, I have a connection. Over here, you see, nothing connected except high. When I put this switch in high. Okay? So therefore, when I just spray the windshield, this is in this position, allowing current to flow here. This in this position, allowing current to flow here. This is the control. Whenever you see a wiper motor controller module, whenever it says control, PCM, BCM, it is a control for something. In this case, we see where it's connected to. If you want to know what it's connecting, what it's controlling. It's controlling this. This is controlling. This is like the input to tell it what I want. And the output is this, the motor, the wiper motor. Okay? Always keep in mind, there's two motors in every circuit. Washer motor for the washer fluid. Wiper motor for the speed to wipe, and depending on the speed, high speed, low speed, how long will the wiper keep on going back and forth? You know, the wiper goes right, low, or it could go high, right? Or it's emitting, right? It could go here, stop, do it again, right? All these are different sequences this control does. Another thing to keep in mind is there are resistors. Resistors will either increase the speed or decrease the speed from low to high. There's many values in the resistors. The higher the value of the resistor, the lower the speed. The lower the resistor value, the higher the speed. Therefore, if I want to lower this speed, I want to go to low, I'm going to have a resistor involved. And you see it is involved. Okay? Now, if I want a high, I'm not going to have a resistor involved in it. And I'll show you what I mean. We said when we want to put washer fluid on the windshield, we engage the button or press the button or the switch. This is what happens. Mist comes here, 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 here. Tells this. Okay, fine. We have something on the windshield, the fluid. We have to get the motor and the wiper to clean it off. This is what it does. And at this speed. Right? It knows by when it comes in here, it knows this is a mist. This is a mist. The mist has been activated. The speed for the mist has been activated. I'll show you what I mean. The next one is, let's say, I don't want this washer motor. I just want to put it on, it's raining, like I said, I want to put it on low speed. Fine. That means this switch now moved to this position, the low position. And this switch is in the low position. And this switch is in the low position, but there's no connection. So the computer, the module is not connected to this right now. This is in low. This is in low. This resistor wouldn't be involved. Again, this resistor will be involved. Right? But this also will be involved. Right? Therefore, it knows low is being activated. Okay? In other words, low is being activated. Low is being activated. It knows. Now, when you want high, which position am I on? This one, and this one, and this one. The fact that it gets B+, over here tells it needs a high position. So therefore, the tricky part to this is Low and high are in the same position over here, the same connection. And you have a resistor also in low and high. But I just told you that you need different resistors, and you don't need a resistor when in high. How does it know? How does it know? Tricky part over here is when this goes to high. When this goes to high, all three of them are in high. This is the only one that's connected, if you only notice. This is the only one that's connected. It gives it a B+. Then it knows, hey, I want a high. I want it in high speed. So in other words, in low, it knows when this is connected to these two, the resistor is in series. I know the control module says, okay, it wants a low speed. Fine. It'll be controlled by this. It'll get 12 volts here. It'll be over here. Get 12 volts over here, but it'll get 12 volts minus this drop. Fine. When you put it in high once more, this over here, this resistor is still involved. This is still involved, 12 volts. But the difference is this one is involved. And when this one is involved, it knows it wants a high. This will be in high speed. Very tricky. Very tricky and very unobvious. Usually you have resistors in different values and you put it in high, low, intermittent, according to that. Not this one. Not this one. This is for Chevys. But what I wanted to point out to you, if you know one sequence, one events, how they work, wiper motors work for one make or model, you could figure out pretty much for the other ones. What I wanted to say is, if you look over here for wiper motors, for Toyotas, for Asian cars, instead of having the module, you have switches. And the same principle applies. As you see, you always have a washer motor, you always have a wiper motor over here. Remember, you also have one in the back also, a wiper motor. And also in the back, a washer. So therefore, depends on the one that you're here. We'll go over it later on. So the washer, in this case, is if you want the washer motor, you look at the switch. The switch over here is connected over here, and it comes out here, and the switch is here, and then it comes out to ground. The purpose is the same. The components are different. So once more, let me reiterate. This is a difficult one. First, the washer. If I want fluid, two things have to be involved. Have to take a notice. The washer and the wiper motor has to wipe it off. If I don't want the washer, it's raining outside, it's snowing, whatever. It's raining, I just want the wiper. This won't be involved because I'm not activating this. I don't need it. However, the speed that I'm choosing is related to this, to the resistors, and to the inputs of this control. So therefore, if I want to put it on the mist, which is this, all three will be in the mist. This is not involved. Only these two are involved, and it gets this one, and it gets this one, right? So therefore, it knows when it gets the B plus over here, it gets a B plus over here, right? It knows it wants a mist. See that? It gets a B plus over here. Forget about this. The only time it'll get less is when this resistor is involved, and that's when low is involved, or high in this one. It is confusing, but you have to really understand how many possibilities there are. There's a mist that's possible. There's a low that's impossible. There's a high that's possible. Again, the mist will give this a 12 volts. So it knows, hey, a mist, it'll give it the proper speed. The low, these two are involved. The resistor is involved. It knows, okay, minus the 12 volt drop. Minus the 12 volt drop. It knows the speed. When high is involved, all three are involved. It knows, it gets the 12 volts from here. It knows, hey, it wants a high speed. Only in Chevys. Boy, only in Chevys. Let's troubleshoot. Now, as I said, I want to spray a mist. I activate the switch for the mist, for washer fluid. Besides the obvious that there is washer fluid, obviously, in the tank, in the container, obviously. We check that. However, I don't hear anything. I don't hear the motor being activated. Now, from troubleshooting, now I'm going to start interpreting and analyzing the schematic from that component. The component that I think that's defective. That's the difference. When you're troubleshooting, if I think there's a problem with this motor, I'm going to start from this motor and work my way back. If I think there's a problem with this, I'm going to work from here, work my way back. If I think there's a problem with the fuse, I check the fuse and it's blown, I'm going to go to that component that's defective and work here, not work back, but work forward to see what this is feeding. That's the difference. Now, as I said, motor, I don't hear the motor working. What do? I go to the switch, back, I trace back. I said, could be the switch. It could be, right? Also could be over here, the fuse. Right? Could be the fuse, could be this. But, if you look, this fuse is common to everything. Look at this. This fuse is also feeding this, which is also controlling this. So if this fuse is blown, guess what? The wiper motor also will not work. It's common to all. See the B plus? This is getting a B plus to this module. No B plus, it can't work. So therefore, if this wiper motor is not working and this is not working, then I'll say it's the fuse. If this is not working, however, the wipers are working, then I'll say, you know what? Fuse must be good. The module must be good because it's getting 12 volts because this motor is turning. What's probably bad? The switch. You understand? Again, washer motor is not working. Wipers are working in speeds. Therefore, I'm concentrating on this path. And what's on this path? Could be the motor. Could be the switch. Either these two. And that's why you have 12 volts here. Now, the washer is working. I see fluid coming out. So I know the motor is getting the 12 volts. Now realize something right now. I did not use a meter. I have not used a multimeter. I am just troubleshooting right now. Pure analyzation. No multimeter. I did not even go to the connector. I did not even go to the motor fan. I'm trying to cut down my troubleshooting time and to try to find the pinpoint to the component before even putting a multimeter. This is the skill, and this is the masterful skill of interpreting and analyzing schematics. Again, I did not put a multimeter to measure 12 volts over here, but I know if this is working, this motor is working, right? I know this fuse must be good. I know this is getting 12 volts. I know this is working. What must be left? This or this. Fine. I'll work from there. Let's say this is giving a spray, a mist. However, I'm not getting the wipers to move. And I'll say, okay, oh, that's easy. That must be the motor, right? Is that true? Let's try it in different positions, and then we'll see. It can be possible that this is broken, this line is broken, and it's not getting it. It's not getting 12 volts. That means the fan won't be, the motor won't be turning. It's true, right? But if I'm not getting it in any speed, right, that tells me it must be this line. If I'm getting it in high, I'm not getting it low, right? High means, okay, so this is working, but these two are not working somehow. If I'm not getting it in low, but I'm getting it in, if I'm getting it in low, but I'm not getting it in high, this tells me this is working. This tells me this is working, but probably this is not working because this is the only one that cuts down the voltage in low. Again, that's how you troubleshoot. Again, when you come to the conclusion, it is spraying fluid, this is working, but the wiper is not moving at all. That tells me has nothing to do with these switches, because if any switch would be involved, one speed would work and the other ones wouldn't work. The fact that everything doesn't work in the wipers on any speed tells me it's either this control module not getting the B+, right? Right? Or this one, this fan itself, or the module itself, or the connector is broken over here. This fuse has to be working because this is still working. Very tough one. Very tough one. Let's go to another one. ASE certification. Questions and answers. If you understood all this, this should be simple. This is a simple diagram for the brake switches, the brake lights. There are 4 of them, right? Over here. See, left rear stop light over here. Left rear stop light over here, right? And over here, right rear stop lights, right? Now, as you see over here, there are 2 filaments, multi-purpose. One is for the stop lights, and the other one is, if you see it, 2 headlights. So one bulb with 2 filaments can have 2 purposes. One for the headlights, one for the brake lights. When is it activated? When you close the switch. Right now, all of them are not lit. What's the problem? If this was asked on an ASE, guess what? It could either be the switch or the fuse, right? If this switch is not active, it's in this position, there's no connection. Therefore, there's no current flowing here, no 12 volts. No reason to go to the connector of each one and measure it if all of them are not lit. You know right away from this schematic, from interpreting it, it's either this or this. If I measure 12 volts over here and I measure 0 volts over here, 0 at the other side, this is open, right? If I measure 12 volts over here and I measure 0 over here, that means there's no connection to the supply, this is open. There's no reason to go, if all of them are not lit, there's no reason to go take out every connector and try to measure 12 volts, because there is no 12 volts. There's no current flowing. So you know what's common to all this. If this would be a question, an ASE certification, I'm sure most of you would get it. If you understood this, for sure you would understand this. Congratulations to